Alright, Algebra 1, here we go. 7-2, scientific notation. You've probably seen this before in your science classes. We use it a lot when we're talking about big numbers, like if you're talking about distances between planets or solar systems or speeds, or if you're looking in a microscope and you're seeing super small particles. We like to write in scientific notation just so we don't have to write out some big numbers with a bunch of zeros. So why would we use powers of 10 to write and compare numbers? For that very fact right there. So we can get numbers down to where we can work with them without all them zeros. So scientific notation is a number written as a product of a number and a power of 10. Remember, product means you're multiplying something, or two things. In this case here, we're going to take a number times 10 to the power n, where this a is between 1 and less than 10. Okay? It's a single digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what we want. There's always going to be one digit to the left of the decimal point. Example, 8.3 times 10 to the 5th. Okay? You're only allowed one digit or number to the left of the decimal point. In this case, it's just 8. 4.21. I don't care how many numbers are after it to the right, but you can only have one to the left, times 10 to the 22. 7.1 times 10 to the negative 5th. Okay, those are examples of scientific notation, numbers written in scientific notation. So, how do you take a number from standard form to scientific notation? You move the decimal point such that there's only one digit to the left. So here, when they don't show the decimal point, it's all the way to the right, correct? And we're going to move it from here all the way to here, so we only have one digit to the left. How many places is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'm sorry, 9. So this is 1.43 times 10 to the 9th, because I moved it 9 places. Remember, everything here in our numbering system here is based on tens, hundreds, thousands, okay, the whole bit there. So however many places you move it, that's going to be your exponent, 10 to that power. All right? And what did I get left over? 1.43. Now I don't have to write all those zeros. Okay? Here, 0.000027. Now we're going to move the decimal point again, so there's only one digit to the left. So I'm going to get 2.7. And I moved it 1, 2, 3, 4, 5 places, so it's 10 to the negative 5th. Now you notice here, positive exponent, negative exponent. How do I know which is which? Which one, when is it positive, when is it negative? Well, if your number of places that you move it, if the number you're working with is bigger than 1, then you're going to end up with a positive exponent, okay, because it's a big number. That's 10 to the 9th power. That's a million. That's a big number, okay? When you got a number that's less than 0 or less than 1, where it's a small fraction or a small decimal, then you're going to end up with a negative exponent. That tells you to move it to the other way, okay? So real small numbers, real big numbers, all right? That helps you out. Okay, so if you got a big number and you go in scientific, positive. If you got a real small number, you want to write it scientific, you're going to get a negative. Okay, and vice versa if you're going the other way with it. All right. Let's look at a couple problems here. Writing in standard form. Let's go the other way. 5.5 times 10 to the 6th, and I want to write it in standard form. Remember what I said. If it's positive, you're going to get a big number. So that tells me I'm going to move this all the way to the right 6 places. 1, 2, 3, 4, 5, 6. So I get 5,500,000. When I see a negative exponent, I'm thinking small. So how do I make this smaller? I move it to the left 3 places. Tack in 2 zeros there, and away you go. 0.0031. Okay? So you're going from scientific to standard or standard to scientific. Okay? Just kind of remember. Big exponent, positive exponent, big number. Negative exponent, little number. Doesn't mean positive or negative number. Okay? Just the size of your number. Say you get something where they ask you to arrange in order. Say for an example, you get this. They give you these 4 numbers in scientific notation, and they want you to write them in order. What you want to do is write them all in the same exponent. Okay? And all that means is just moving the decimal point. I want to bring all these to the 7th power, so I'm going to leave these first 2 alone. This one, to make it to the 7th power, since this went down, this has got to get bigger. Okay, remember, this means big numbers. So I'm going to move it one place over so I get 10.6 times 10 to the 7th. It's not in scientific notation anymore because there's 2 digits to the left, but for what we want to do, it's going to work for us. Same thing here, I'm going to drop it down 1, so I got to move the decimal point 1, I get 18 times 10 to the 7th. Now from least to greatest, I can write them in order from least to greatest. When they're all in the same notation, the same exponent, then it's just a matter of smallest to biggest with the numbers out front. Okay? So if you get something like that, that's what you want to do. And your final answer, if you want to turn that back to be 1.06 times 10 to the 8th, 1.8 times 10 to the 8th, you can, because you now have them in order. Okay? So get them in the same exponent there. So that's all we got with this section here. We'll keep working with exponents as we go. We'll look at some examples of this. Hopefully you're using this kind of stuff in your science classes already. And we'll pick up on that tomorrow. We'll look at some application of it. All right, have a good one. Bye.